Okay, today we are going to perform a practical which is known as PN junction characteristics. So I think in theory part you might have studied. So very simple practical. So what we have to do is that we normally say the cutoff voltage of diode is zero point 0.4 or zero point 0.7, depends upon whether it is made up of silicon or whether it is made up of germanium. Okay. So here practically today we will see what is the breakdown voltage and what happens when we cross the breakdown voltage, and what will happen to the current which is flowing to the diode, that is forward current and forward breakdown voltage. Okay, so please come here. So this was the setup. This is a breadboard for which we have to mount a circuit made up of diode and a resistor. This is my DMM. Okay, so these are breadboards. Okay, so here we have mount the components. Then these are your DMMs. Okay, so this we use as a voltmeter, and this DMM or digital multimeter we can use as a current meter. Okay, and this is a dual power supply from which we have to supply the voltage. Okay, so for that first we'll draw the diagram. Okay, okay, focus on here. Huh? So this is a very simple diagram which I will draw here. Okay, so this is a power supply, variable power supply. So this is a symbol for a variable power supply. So we are taking the range of 0 to 1 volt. Okay, this is a resistor. Normally we can use a resistor of 100 ohm or 1k, whatever be. And this is your ammeter, which positive sign here, negative sign, and this is my diode. Okay, and across which we have to connect a voltmeter to measure the voltage. Okay, so this is a simple circuit which I am drawing, and obviously this is a common ground. Fine. So I will draw the graph also. This is a normal graph which we have to observe while doing a practical. Okay, this is a voltage axis and this is a current axis. Okay, so I can make it as forward current, I can make it as forward voltage. Okay, so this is a graph. We can normally see something like this. So this is a cutoff voltage or breakdown voltage. What is this cutoff or breakdown voltage? Okay, so when we apply the voltage across the diode, so normally we start from 0 volt. Okay, so when we apply the diode to 0 volt, the diode won't respond. Means what? No current flows. So likewise we keep on increasing the voltage from 0 volt to 1 volt to 0 volt, 0.1 volt, 0.2 volt, 0.3 volt, unless until we reach to the cutoff voltage. So what happens once you reach the cutoff voltage, or once the cutoff voltage is applied across the diode, so diode will start conducting. Because of that result, what will happen? The current will flow exponentially. Okay, so this is the graph which we have to plot it, which we are getting. So obviously we will have to plot by mounting this circuit component. So here what we have to mount is that here we have to mount the resistor, here we have to mount a diode. We are using IN4001 diode. Okay, and this is ammeter. Okay, this is a plus and minus sign, plus and minus. So accordingly we can map this circuit in a breadboard. Okay, so have a look on a breadboard. Okay, so I put our circuit over here and just explain. So you can imagine, so this is a plus terminal. Okay, okay, so this is a plus terminal which is connected to a 100 ohm resistor. Then 100 ohm resistor is connected to the plus terminal of the ammeter likewise. So this is a power supply plus terminal, this is a plus terminal. Okay, so look at here, this is a plus terminal. Okay, this is a plus terminal, right? So this is my plus voltage here, plus terminal. So this plus terminal why we have taken, okay, we are given to the one end of the resistor. So this is what one end of the resistor. The other end of the resistor is connected to what? Ammeter, that is a positive terminal. So this other end of the terminal is connected to the positive terminal. Okay, then other end of the terminal of the ammeter is connected to the anode of a diode. So this is connected to the anode of the diode. Okay, then the anode of the diode is connected to the ground. So here it is connected to ground, this one. Likewise, other end of the terminal of the diode, that is this one, is connected to the positive terminal of the voltmeter. So this is a positive terminal of the voltmeter, isn't it? So this is connected to the diodes. Okay, which one? Anode part. and the cathode is grounded. Okay, so this is what the circuit diagram. Okay, you just show here. Okay, so this is a power supply, so which resistor is connected. To this resistor we are connected series ammeter. Okay, the other end of the ammeter is connected to the diode. Fine. The other end of the diode is also connected to the voltmeter here, and this is what the circuit. So what you have to do is that here you vary the supply voltage. Okay, the supply voltage is shown here. You vary the supply voltage and you see the corresponding change in voltage and change in current. This we are using as a voltmeter. Okay, DMA means what? This is a multi-purpose. You can measure the resistor, you can measure the voltage, you can measure the current. So right now I am assigning this digital multimeter as a voltmeter. So this will measure the voltage. Likewise, this digital multimeter I assigned as a current, that will measure the current. So what we have to do is that we have to see the reading. So what I said, unless and until a breakdown voltage is reached or cutoff voltage will reach, the diode will conduct. Otherwise, the diode will not conduct. So when diode will not conduct, obviously leakage current, or you can say small current, will be available. So here we are putting our DMM in microampere, right? That is 10 to the minus 6 ampere. So we have to measure a very small current. No, so that will be that range will be fitted in a microampere. Okay, and this I put in a voltage, that is a DC voltage and DC current, right? So here this is a now for which I am varying the voltage. Okay, so when I am varying the voltage, you see this what is reading we are getting here and here getting. So here the current is 0. We just show here. Yes, you are showing the current is 0 here. No current is flowing. Okay, now my voltage is approximately, you can say 0.1 or 0 volt. Okay, fine. And this is the voltage. So if I vary, so what we have to see is that the moment it reaches the cutoff voltage, the current will drastically increase. This one. Okay, so here once the breakdown voltage will reach, there will be a sudden formation of current. Current will flow, and again if you increase the cutoff voltage, what will happen? The current will flow exponentially. Fine. So what we have to do is that we have to take a step of voltages and the current, and we can plot a graph. So slowly I am changing this current. Okay, see here. So I am varying here current. So this is now 0.2. You can see no current is flowing here. Now I am varying this knob so that you can have observation. From 0.3 we are getting a very minute current, right? 4 volt. Then if you are increasing a 5 volt, then the moment you are increasing the voltage, see 0.4, right? You see the current is drastically increasing like this. And if you keep on increasing the voltage from 0.6, 0.7, you can see how drastically the current is increasing, isn't it? Likewise, see what is the current. Likewise. Okay. Again, if I reduce the voltage, see, look at here. If I again go below this, cut down voltage, right? So hardly you will find some current. This current is flowing because of some reverse leakage current. Okay. So you got to understand. So the moment you voltage reaches to cutoff voltage, right? Your current will. Okay, so this is the whole circuit diagram regarding the forward bias. So you can say this is forward biased PN junction diode characteristics. Okay, so same can be done for a reverse characteristics. So what we have to do is that here, instead of diode, we have to reverse the position of diode. Likewise, we have to. So this configuration is for nothing but reversed biased PN diode. Okay, so same practically you have to do. If you reverse the direction of the diode, that is this one, we can directly do the reverse character of the PN junction diode. Okay, so I think you have clearly understand. In theoretical you might have studied. So practically this is very simple circuit by which you can do this PN junction diode. Okay. So in next practical we will do I think which one, a Zener diode characteristics. Okay. So in next practical I will shoot a video on Xeno diode, and we will see how the Xeno diode operation is been done, and practically we can verify the graph. Okay. So thank you for this watching this video. Thank you.